Hello students, in today's lecture we will study about ideal and non-ideal solutions. This is a very simple chapter but descriptive in nature. Please listen to the lecture carefully and note down all the important points. I welcome you once again. Ideal and non-ideal solutions. Liquid-liquid solutions can be classified into ideal and non-ideal solutions on the basis of Raoult's law, which we have studied in section number 1.4. Raoult's law states that for a solution of volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction present in the solution. Thus, for component 1, P1, that is vapor pressure P1 is proportional to X1, that is the mole fraction. So, eliminating the proportionality constant, P1 equals P1 naught X1. Here, P1 naught is the vapor pressure of the component 1 at the same temperature, and X1 is the molar fraction. Similarly, for another solution P2 is equal to P2 naught X2. Here P2 is the vapor pressure of solution 2 and P2 naught is the vapor pressure of pure component 2 at the same temperature. X2 is the molar fraction of solution 2. So, combining P1 and P2, P total is equal to P1 plus P naught, P1 plus P2. Please see the graph. The graph on the screen shows the plot of vapor pressure and mole fraction of an ideal solution at constant temperature. The dashed lines 1 and dashed line 2 represent the partial pressure of components. It can be seen from the plot that P1 and P2 are directly proportional to X1 and X2 respectively. The total vapor pressure is given by the line marked 3 in the figure. That is, this line shows the total pressure. This is for solution 1 and this one for solution 2. And this mole fraction is plotted on the x-axis and vapor pressure on the y-axis. This we have already learned in section number 1.4. Ideal solutions. The solution which obeys Raoult's law over the entire range of concentration are known as ideal solutions. I repeat, the solutions which obey Raoult's law as over the entire range of concentration are known as ideal solutions. Ideal solutions have two important properties. The enthalpy, that is delta H of mixing of pure components to form the solution, is 0. That is delta H mix equal to 0. And the volume of mixing is also 0. That is delta mix of V is equal to 0. So we will write the equations mathematically. Therefore, it is shown on the screen delta mix H, that is heat, equal to 0, delta mix volume V equal to 0. Let it be equation 21. It means that here the above equations show that no heat is absorbed or evolved when components are mixed. Also, delta mix V equals 0 shows that the volume of solution would be equal to the sum of volumes of the two components. At molecular level, ideal behavior of solutions can be explained by considering two components A and B. In pure components, the intermolecular attractive interactions will be of types AA and BB, whereas in binary solutions, in addition to these two components, AB type of interactions will also be present. If the intermolecular attractive forces between AA and BB are nearly equal to those between AB, this leads to the formation of an ideal solution. A perfectly ideal solution is rare, but some solutions are nearly ideal in behavior. The examples of ideal solutions are solutions of N-hexane and N-heptane, bromoethane and chloroethane, benzene and toluene, etc. fall into this category. Non-ideal solutions. When a solution does not obey Raoult's law over the entire range of concentration, then it is called non-ideal solution. The vapor pressure of such a solution is either higher or lower than that predicted by Raoult's law. So Raoult's law, writing mathematically, we can write Raoult's law as P total is equal to P1 naught plus P2 naught minus P2 naught into X2. Here P1 is the vapor pressure of solution 1 pure in the pure state. P2 naught is the vapor pressure of the solution 2 in the pure state, and X2 is the molar fraction. If it is higher, the solution exhibits positive. So if the vapor pressure is higher and it exhibits positive deviation, I mean it is lower, P total is lower, then it exhibits negative direction from Raoult's law. The plot of vapor pressure as a function of mole fractions for each such solutions are shown in the figure above. Here in the figure shows the mole fraction versus vapor pressure for two mixtures or two solutions. The vapor pressure of two components systems as a function of composition. Here in figure a solution that shows positive deviation from the Raoult's law. So the Raoult's law, the green line is, it obeys Raoult's law, and this is a positive deviation from Raoult's law. And this in figure B, if we plot vapor pressure versus mole fraction, it is showing a solution shows a negative deviation from Raoult's law. So recapitulating, when a solution does not obey Raoult's law over the entire range of concentration, then it is called non-ideal solution. The vapor pressure of such a solution is either higher or lower than that predicted by Raoult's law. So Raoult's law, the total pressure, as per the Raoult's law, total pressure is equal to P10 plus P2 minus P2 minus into X2. If it is higher, the solution exhibits positive deviation, and if it is lower, it exhibits negative deviation as shown in the figures above. The plots of vapor pressure as function of mole fractions for each of these solutions are shown in the figure above. Non-ideal solutions, positive deviation. In case of positive deviation from Raoult's law, AB interactions are weaker than those between AA or BB. That is, in the case of intermolecular attraction, forces between the solute-solvent molecules are weaker than those between the solute-solute and solvent-solvent molecules. This means that in such solutions, molecules of A or molecules of B will find it easier to escape than in pure state. This will increase the vapor pressure and result in positive deviation. Mixtures of ethanol, acetone behave in this manner. In pure ethanol, molecules are hydrogen bonded. On adding acetone, its molecules get in between the host molecules and break some of the hydrogen bonds between them. Due to weakening of interactions, the solution shows positive deviation from Raoult's law as shown in the figure. This is the positive deviation. In a solution formed by adding carbon disulfide to acetone, the dipolar interactions between solute-solvent molecules are weaker than the respective interactions among the solute-solute or solvent-solvent molecules. This solution also shows positive deviation. Non-ideal solutions, negative deviations. In case of negative deviations from Raoult's law, the intermolecular attractive forces between AA and BB are weaker than those between AB and leads to the decrease in the vapor pressure resulting in the negative deviations as shown in the figure. This is the negative deviation. So we will take an example. An example of this type is a mixture of phenol and aniline. In this case, the intermolecular hydrogen bonding between phenolic proton and a lone pair of nitrogen atom of aniline is stronger than the respective intermolecular hydrogen bonding between similar molecules. Another example is mixture of chloroform and acetone. A mixture of chloroform and acetone forms a solution with negative deviation from Raoult's law. This is because chloroform molecule is able to form hydrogen bond with acetone molecule as shown. This is the chloroform with acetone. This decreases the escaping tendency of molecules of each component and consequently the vapor pressure decreases, resulting in negative deviation from Raoult's law as shown in the figure graph. Azeotropes. Some liquids on mixing form azeotropes, which are binary mixtures having the same composition in liquid and vapor phase and boil at the constant temperature. So the properties of azeotrope is, first, they are having same composition in liquid and vapor phase. They boil at constant temperature. In such cases, it is not possible to separate the components by fractional distillation. Distillation is the process of separating the components. There are two types of azeotropes called minimum boiling azeotropes and maximum boiling azeotropes. Minimum boiling azeotropes. The solutions which show a large positive deviation from Raoult's law form minimum boiling azeotropes at a specific composition. So minimum boiling is which show large positive deviation. Please underline this. For example, ethanol-water mixture obtained by fermentation of sugars on fractional distillation gives a solution containing approximately 95% by volume of ethanol. Once this composition, known as azeotrope composition, has been achieved, the liquid and vapor have the same composition and no further separation occurs. Maximum boiling azeotrope. The solutions that show large negative deviation from Raoult's law form maximum boiling azeotrope at a specific composition. So, maximum boiling azeotropes show large negative deviation. So, components showing large negative deviations are maximum boiling azeotropes, whereas components which show large positive deviations are minimum boiling azeotropes. Nitric acid and water. Mixture of nitric acid and water is an example of this class of azeotrope. This azeotrope has the approximate composition 68% nitric acid and 32% water by mass with a boiling point of 393.5 Kelvin. Let us summarize the properties of ideal and non-ideal solutions. Ideal solutions. Ideal solutions obey Raoult's law at all temperatures and concentrations. Non-ideal solutions do not obey Raoult's law at all temperatures and concentrations. In the case of ideal solutions, P1 vapor pressure P1 is equal to P1 naught x1 and P2 is equal to P2 naught x2, where P is the vapor pressure and P1 naught is for pure substance or pure component. And for non-ideal solutions, P1 is not equal to P1 naught x1 and P2 is not equal to P2 x2 naught. In case of ideal solutions, delta mix H is equal to 0 and delta mix V volume is equal to 0. Whereas in the case of non-ideal solutions, delta mix H is not equal to 0 and delta mix V is not equal to 0. The next property is, in the case of ideal solutions, A-B interactions is equal to A-A and B-B interactions. Whereas in non-ideal solutions, A-B interactions are not equal to A-A and B-B interactions. The ideal solutions do not form azeotropes, that is constant boiling mixtures, whereas the non-ideal solutions form azeotropes. Next we will take up non-ideal solutions showing positive and negative deviations from Raoult's law. So these are the all are non-ideal solutions, but as you have seen, there are positive deviations and negative deviations from Raoult's law, and graphs you have seen already. So in the case of solutions showing positive deviations, A-B is less than A-A or B-B interactions, whereas For negative deviation solutions, A dash B is greater than A dash A and B dash B interactions. In case of positive deviation solutions, delta mix H is greater than 0 and delta mix V is greater than 0, whereas these two parameters are less than 0 for negative deviation solutions. In the case of positive deviation solutions of non-ideal solutions, P1 part vapor pressure Pi is greater than P1 naught into Xi, whereas in case of negative deviation solution, P1i is less than P1i0 into Xi, where here Xi is the molar fraction. The positive deviation solutions form minimum boiling azeotrope, whereas negative deviation solutions form maximum boiling azeotrope. Examples of positive deviation solutions are ethanol and acetone, carbon disulfide to acetone, methanol and water, cyclohexanol and cyclohexane. The examples of negative deviation solutions are phenol and aniline, chloroform and acetone, chloroform and benzene, water and H2SO4 or HNO3 or HCl. Please summarize and remember. Now we will answer some of the selected multiple choice questions. For an ideal solution with P1 greater than P2, which of the following is true? Four options are given. Option A is X1 under liquid equals X1 under vapor. Option B is X1 in liquid state greater than X1 in vapor state. Option C, X1 in liquid state less than X1 vapor state. Option D, X1 liquid state and X1 vapor state do not bear any relationship. Let us analyze it first. As one is more volatile, vapor phase would be richer in 1. Hence, X1A of liquid in liquid state will be less than X1 in vapor state. This option is available as C. Please mark it. Next, what are the conditions for an ideal solution which obeys Raoult's law over entire range of concentration? Once again, four options are given. So option A, delta H of mixture equals 0, delta V equal to 0, and P total is equal to P1 naught X1 plus P2 naught X2. Option B, delta mix of H equals positive and delta mix of V is equal to 0 and P total is equal to P1 naught X1 plus P2 X2. Option C is delta mix of H equal to 0, delta mix of V equal to positive, P total is equal to P1 naught X1 plus P2 naught X2. Option D is delta mix of H equal to 0, delta mix of V equal to 0 and P total is equal to P2 naught X2. So you please analyze it. For an ideal solution, delta H and delta V for mixing should be 0. Therefore, P total equals P A plus PB and A minus A, comma A dash A, comma B dash B and A dash B interactions are nearly same. Therefore, option A is the correct answer. Next question. Intermolecular forces between N-hexane and N-heptane are nearly the same as between hexane and heptane individually. When these two are mixed, which of the following is not true about the solution formed? Four options are given. Option A, it obeys Raoult's law. P1 is equal to P1 naught x1, P2 is equal to P2 naught x2. Option B is delta mix of H is equal to 0. Option C is delta mix V equal to 0. And option D is it forms minimum azeotrope. Please analyze for a while and note that azeotropes are formed by the solutions which show deviations from ideal behavior. So, option D is the correct answer. Next question. Which of the following solution shows positive deviation from Raoult's law? So, four options are given. Option A, acetone plus aniline. Option B, acetone plus ethanol. Option C, water plus nitric acid. And option D, chloroform benzene. So, please analyze for a while and note that acetone plus ethanol is an example of solutions showing positive deviation from Raoult's law. Since acetone ethanol attractions are weaker than acetone and ethanol interaction. Hence, option B is the correct answer. Please mark it. Next question. Next question. The system that forms maximum boiling azeotrope is, they are given four options. Options A, options B, option C and option D. Acetone dash chloroform, ethanol and acetone, N-hexane and N-heptane, carbon dioxide and acetone. You have to identify the correct answer. Please analyze. Due to stronger intermolecular interactions for acetone and chloroform, lesser number of molecule vaporites resulting in low vapor pressure and high boiling pressure. Hence, option A is correct. Next question. Which of the following solutions is an example of negative deviation from Raoult's law? Four options are given. Option A, acetone plus ethanol. Option B, CCl4 plus chloroform. Option C, acetone plus chloroform. Option D, water plus ethanol. Please analyze it. CH3COH3 plus CHCl3 is an example of solution showing negative deviations from Raoult's law. Since A-B attractions, that is acetone plus chloroform, are more than A-A, that is acetone-acetone, and B-B, chloroform-chloroform attraction. Hence, option C is the correct answer. Please mark it. Next question. Study the figures below and mark the correct statement. Two figures are given, one for positive deviation and the second one for the negative deviations. This we have studied in today's session itself. So, four options are there for graph A, water plus nitric acid. For graph 2, acetone plus ethyl alcohol. So these are the examples of, that is, positive deviations for graph 1 and negative deviation for graph 2. Similar choices are given. You have to identify the correct one and mark the correct answer. That is, acetone plus ethyl alcohol solution shows positive deviation while acetone plus chloroform shows negative deviation. Hence, you have to mark option C as the correct answer. Next question. Few mixtures formed by two components are given. Which of the following binary mixtures will have the same composition in liquid and vapor phase? So, one is mixture of ethanol plus alcohol. Number 2 is water plus nitric acid. Number 3 is benzene plus toluene. Number 4 is ethyl chloride plus ethyl bromide. So, 4 options are given and you are to identify which will have the same composition both in liquid and vapor phase. Option A, that is mixture 1 and mixture 3. Option B, mixture 1 and mixture 2. And option C, mixture 1, 2 and 3. And option D is 3 and 4. Let us analyze it. So, 3 and 4 will form ideal solutions. Hence, do not form azeotrope. Azeotrope have same composition in liquid and vapor form when distilled. Hence, option B is the correct answer. You please mark it. With this, we come to the conclusion of ideal and non-ideal solutions. In the next lecture, we will take up section 1.6, that is colligative properties and determination of molar mass. Till then, goodbye.